Hello guys, and welcome back to my video tutorial. If you can remember the last time we ended with chapter 7 where we were talking about IP version 4 address. We were just talking about IP, and here we're going to talk about IP version 4, and we look at the difference between IP version 4 and IP version 6. It will just be a very quick video, guys, so I hope you guys enjoyed your holiday. And we're resuming, and it's unfortunate that we have to manage this way, so we get things running fast so we can complete quickly. So I hope you guys catch up with me quickly. The videos will be very short and precise. So before we talk about IP, we have addresses that are involved. So first, in this video we first need to learn how to convert from decimal to binary, because IP version 4 address is a 32-bit address long. It is 32 bits, and those 32 bits, let me just write that, IPv4 is 32 bits long, so we just have to look at that. Okay, 32 bits long address. So what it does is that it has a range of just 32 bits, and these 32 bits are divided into 4 of 8 bits. So each of those 4, so we say IP version 4 is divided into 4 parts. Okay, so let's just take it like that, 4 parts, and those parts are referred to as octets. So we just look at that. So 4 parts, and each part consists of 8 bits. So we say each part of the IP version 4 address consists of 8 bits. So when you have 4 of 8 bits is equals to 32 bits. So actually this is exactly what we're looking into as IP version 4 address. Okay, so before we go into those addresses, so we have to just understand, for instance, IP version 4 address look like this, just like this. So this is just a simple typical IP version 4 address. So these portions are divided by dots. So you have 8 bits here, we have 8 bits as 168, we have this one as 8 bits, and we have other 8 bits. So how do we get this 192.168.1.1? How do we know the binary equivalence of this decimal IP version 4 address? That is what I have to show you guys first. Before you understand about IP version 4, you need to know how to convert from a decimal number to binary, and from binary to decimal, like we did with hexadecimal conversion. So basically that is exactly what I'm going to do with you guys. So in order for you to convert from decimal to binary, you have to understand your bit value. So we said we have 8 bits. Okay, 8 bits in IP version 4 address. So those are the 8 bits that we have right there. So these 8 bits, we can say they are let's say this is going to be 7 6 5 4 2 3 1. So that is it, 3 2 1. That is this one and this and this. So these are the number of IP version 4 addresses that we have. So we can look at just right from that. Let me just reduce that a little bit, sorry about that. Oh yeah, light is gone from my area, so I think my house is going to get a little dark, but still we can just continue with that. Maybe in my next video I'll try to shut down my video, so it will just be direct, you'll just be taking my voice. Okay guys, so we have this number of bits. We have 1 2 3 4 all the way 5. So this number is what I have to look at immediately and try to sort it out. Okay, so that's the number 1 2 3 4 5 6 7, starting from right towards the left. So right now what I am looking for is the values of each of these bits. So how do I get those values? Is that I have to put 2 as the radix right here. That is 2 to the power of 1, 2 to the power of 2. So I am going to multiply, or I'm going to raise to power all these numbers that I have here into 2, so I can get the bit values right there. So what I am looking for is, when I say, for instance, 2 to the power of 1, in lots of indices, any number to the power of 1 is 1. So I am looking for 1. So basically, because I am using Microsoft Word, it will not be able to give me exactly what I'm looking for. So, but what I am looking for right here is 1, and 2 to the power of 2 is 2. 2 to the power of 3 is 4. Sorry, is sorry. 2 to the power of 1 is 2. Sorry, I'm supposed to start with 0 because I do not have all the numbers. That is how much? 1, 2, 3, 4, and 1, 2. So I am left with one number here, one more 0, because that was supposed to be a 0. Okay, any number to the power of 1 is that number. So I made a mistake with that. So when I say 2 to the power of 0 equals to 1, 2 to the power of 1 equals to 2, 2 to the power of 2 equals to 4, 2 to the power of 3 equals to 8, 2 to the power of 4 is equals to 16, 2 to the power of 5 is equals to 32, 2 to the power of 6 is 64, and 2 to the power of 7 is 128. So basically that's how you're gonna have it. So the bit values are 128, 64, 32, 16, 8, 4, 2, and 1. So these are your bit values. So this is how you get those bit values. You put 2 right underneath this one, and that's so. Let me just put this right here so you guys can see. The formula is very simple. 2 to the power of 7. So this 7 has to be a superscript. So I'm gonna have to work on that. So this 7 has to be